Good morning, everybody. This is Peyton with the Automotive Training Institute. Give me a few minutes and I'll explain to you why you're having such carbon deposit issues on your modern engines. It's a very complicated subject, but give me a few minutes and I'll explain it to you.
It's a complicated process, but not at all difficult to understand when you realize that every drop of crude oil is a mixture of many small particles or molecules. The crude oil is heated in a furnace, and the hot oil is pumped into a fractionating tower. The proper temperature is maintained in the tower by recirculating part of the oil through the furnace. The heavy molecules in liquid form concentrate at the bottom of the tower and are drawn off for use as heavy oil.
I wonder what they're going to do with all those heavier
lighter
oils.
Molecules vaporize, and with the natural gases move to the top of the column. This straight run was the only kind of gasoline we had. But as public demand increased, new ways had to be found to get more gasoline from a given amount of crude oil. So the oil industry developed what is called the thermal cracking process. Certain of the larger molecules of heavy oil are literally cracked into smaller molecules in or near the gasoline range.
Different hydrocarbons condense out of the gas cloud when the temperature drops below their specific boiling point. The higher the gas rises in the tower, the lower the temperature becomes. The precise details are different at every refinery and depend on the type of crude oil being distilled. But at around 260 degrees, diesel condenses out of the gas. At around 180 degrees, kerosene condenses out. Petrol or gasoline condenses out at around 110 degrees, while petroleum gas is drawn off at the top. The distilled liquid from each level contains a mixture of alkanes, alkenes, and aromatic hydrocarbons with similar properties, and requires further refinement and processing to select specific molecules. The quantities of the fractions initially produced in an oil refinery don't match up with what is needed by consumers. There is not much demand for the longer chain high molecular weight hydrocarbons, but a large demand for those of lower molecular weight, for example petrol. A process called cracking is used to produce more of the lower molecular weight hydrocarbons. This process breaks up the longer chains into smaller ones.
The cracking and reforming of these molecules is totally fine until you start mixing alcohol with it, or what we call ethanol.
Forming involves the breaking of straight chain alkanes into branched alkanes. The branched chain alkanes in the 6 to 10 carbon atom range are preferred as car fuel. These alkanes vaporize easily in the engine's combustion chamber without forming droplets, and are less prone to premature ignition, which affects the engine's operation.
So what's going on here is they're breaking down these 32 carbon chain molecules into a 6 to 8 range to be able to use them as gasoline. They're able to take these and be able to sell them as gasoline. There's nothing wrong with that until you start adding alcohol. What alcohol does is it starts to break them down. When it's breaking them down, their tacky properties are starting to come back. Before they were road tar and asphalt and stuff like that, now that tacky property is coming back into the 8 carbon chain molecule that we have and we're using as gasoline. When that gasoline fires in the car, it's becoming tacky and the carbon molecules are starting to stick to things. That's why we're seeing such carbon buildup in motors, is because of the ethanol that was added to the fuel.
7-year mechanic Trevor Carpenter says he has absolutely seen an ethanol impact since it was introduced to fuel back in 2007. And he says it is not in a good way.
Now, we see this problem a lot with small engines because what do small engines do? They sit and they don't get serviced. And the alcohol builds up in the gas and absorbs water.
People have been coming in with problems?
Left and right.
Trevor says that because ethanol is an alcohol, it acts kind of like a cleaning solution inside engines, which ironically is a bad thing. He says that ethanol often removes the gunk from inside of an engine, but then deposits that gunk somewhere else that it doesn't belong.
This is because what the alcohol does a really good job of doing is cleaning up everything in the fuel tank and forcing it through the fuel system into the injectors and clogging them up. Obviously, this is a really big problem when you only have one injector in a carburetor, like in a leaf blower or a snow blower or something like that. However, in an engine, it takes time for this to happen. Over a period of time, you get all that gummy stuff starts to get built up in your fuel injectors, and then it starts attracting deposits to stick to them, and then as the ethanol burns hotter, it bakes them on.
All the little debris and such that it's helping to clean up is getting lodged up into the jets and preventing the machine from getting the proper amount of fuel.
And as an alcohol, Trevor says ethanol burns hotter. We put together a test using 2 identical brand new leaf blowers. We put standard 10% ethanol gasoline into one and an ethanol-free gasoline into the other. We fired them up at the exact same time, waited a few minutes, and then took a temperature reading. We found that the blower that was using gas that does contain ethanol was nearly 100 degrees warmer. By adding water to these jars of different fuels, Trevor showed me the problem that can come with months of moisture seeping into a stagnant gas tank. While water and gas is never a good combination, ethanol gas bonds with the water. You can see how that ethanol and water make a white, cloudy gunk. And that stuff you say is bad for engines?
Yes.
And that, Trevor says, leads to the most common complaint he hears as a small engine.
So like you just saw, ethanol absorbs water. When it does, it gets gooey. When it gets gooey and it goes through your motor, that's what keeps the carbon deposits sticking to things, and as it burns hotter, it bakes them onto the valves. That's the reason we're having so many problems. If you have any questions, please shoot me an email. npeyton, so N-P-E-Y-T-O-N, @autotraining.net. Love to hear from you, and anything else I can do, just let me know. Thanks so much.